So welcome students. So now I'm going to explain you how to work with the full wave rectifier. So earlier we have seen with the half wave rectifier. So now we are going to see the bridge configuration. Actually full wave rectifiers can be done in any of the two modes. Okay. So one is called as a center tap. In the center tap we make use of two diodes, whereas in the bridge configuration we make use of four diodes. So I will explain you how to work with the four diodes. See here in the configuration we can able to see here we are having one diode, okay, and here we are having one diode, okay, and then this is one point. So let me take this is one point, okay, and again this is one point, okay, this is one, and here, and now it starts from here we can able to see one more diode. So here we can able to see here our point is there, here our point is there, and this point is connected to your things. So let me name this diode as diode D1 and D2 and D3 and D4. As I said, you are having the four diodes. So here the 230 volt 50 hertz AC supply is given input. So let me take this is a 0, this is 230 and 0 and this is 12 because I am using a 230 volt 12 bar step down transformer. Okay, so now when I turn on, what is happening, so I'm going to measure the input supply. So input supply, you will get a AC power supply like this. So I'm measuring the AC power supply. So this is called as the one full cycle. So one full cycle means it is composed of positive cycle and negative cycle. So during positive cycle, what is happening, this diode D1 and D2 alone will conduct. That is diode D1 and D2 alone will conduct, while and D3 and D4 will not conduct. So while conducting, what will happen, the flow of current will be like this. That is, it starts from 12 and reaches like this. Because diode is conducting, it moves like this. Okay, so let me take and connecting a load at the middle. Okay, let me take a load, a resistive load I'm keeping over here. So diode D1 is conducting, comes over here, moves with the resistor, and then comes with the D2 and reaches this point and over here. So during this conduction, you can able to see this particular conduction touches this point, touches this point, and touches this point, and touches this point. All the 4 points being dealt with this particular person. Similarly, what is happening in the negative of cycle? In the negative of cycle, we can able to see diode D3 and D4. It starts to conduct. How it is conducting? It starts from 0 and moves with the D3, goes with the resistor and goes like this and finally reaches this one. So while it is moving in the positive of cycle, diode D1, D2 are conducting, while in the negative of cycle D3, D4 are conducting. So all the four diodes are conducting for this full cycle, where two diodes for the positive of cycle and two diodes for the negative of cycle. So here in this experiment, okay, so what we are going to see, so we are going to see this input waveform. So you will get output waveform like this. You'll get output waveform like this, that is without filter, and now finally with the filter you will get a straight line like this. It's not a straight line, you will get a line like this. Okay, when you zoom it out, you will get the things like this. So we are going to measure what is the voltage and what is the frequency for your input, and what is the voltage and what is the frequency for your with filter and without filter elements. Okay, so now we are going to solve this experiment. Okay, so first initially we are going to give the breadboard connection. Okay, so in the breadboard connection, okay, in the breadboard connection, so we are going to connect the diodes as like what I shown here. Okay, so here we are having the four diodes. Let you take how I'm going to connect the diodes. Okay, so ಎಲ್ಲ diode mix ಆಯ್ತು. So we kept here, so no problem. Okay, so here I can able to see I'm going to connect the diode D4. Okay, so anyway, I can able to show with this particular diagram. I'm going to connect the bridge like this. So by this you can able to understand how I'm going to connect it. It's very interesting experiment. Okay, so here one point, here one point, here one point, and here one point. So I'm going to use four diodes. 1, 2, 3, 4. Okay, so four diodes. First I'm taking this diode. Let me assume this is your D1. Okay. And secondly, I'm taking this diode and inserting as like your half-wave rectifier, guys. In your breadboard, you're inserting. It's very, very hard to insert. One diode is connected. Another diode is connected, and then I want to connect the third diode. You should measure that, so this point, this particular point, the rounded point is this one. So in the rounded point we can able to see two connections. The two connections are given here, and here two. Okay, so this particular point, this point is here. Okay, so on this point is here. So anode, cathode, anode, cathode, anode, cathode. The last one is this particular diode I'm going to give. So we get the 4 arms like this. 4 arms. Okay. Okay, fine. So we have given the connections for the bridge. 1 arm, second arm, third arm, and fourth arm. So in the column wise, you should see that no 2 columns are touching in the same line. Okay, if then it will create a short circuit. Okay, so now what you're going to do, so in the topmost arm, I want to give the 12 volt. The downmost arm, I want to connect the 0, and these 2 arms I'm connecting the resistor. That's all. For a full bridge. So here I'm connecting the 12 volt. It is connected to the top arm. Okay, top arm, and this 0 I'm connected to the bottom arm, and I'm making a resistor. Okay, so this resistor I'm connecting quite nearby a resistor. Okay, resistor. So this resistor I'm connected to the another couple of arms. So here I want to measure the input and output. Okay, so the waveforms and its corresponding readings I will get. We have to take it. And this is given to here. Fine. Okay, so now the connections gets over. So now what I'm going to do, I want to measure the input. So while measuring the input, I can able to see this is the you can able to see. We turned on. Okay. Fine. So because as I already showed you that how to take the output, that's a input for the half-wave rectifier. Similarly here also I'm connecting the 0th point, and I am connecting this point. Okay, so while we are taking this, we will get a sine waveform. So as I mentioned you, while taking the sine waveform, okay, I want to take the voltage. So here we are taking that it is consumes 4 boxes multiplied by it's not 4 boxes, 2 boxes. That is here 1 box, 2 box. You can able to see 2 box it covers. So 2 box into 10. So I will get 20 volt. Similarly, a time period I can able to see 1, 2, 3, 4 boxes. That is 1 box here, 1/3, second box, third box, 4 box. So 4 boxes into, you can able to see the black color over here. It marks the 5. So 5 4s are 20 millisecond. So this is for my input. Okay, so now I'm going to measure the output. Okay, so while taking the output, so I can able to take this positive, and I'm going to see what is the corresponding output. Sorry, so here I want to take it out. Okay, across the ground, across the load, you can able to see. Oh my goodness, you can able to see. I can able to get the full wave output. So while taking the full wave, you can able to see it conducts for both the half cycles. The half wave rectifier, it conducts for only one half cycle, it conducts for all the half cycles. Okay, that's a full wave rectifier. So you can able to see for this particular circuit, the voltage is equal to, we can able to see again 2 boxes multiplied by, so here we can able to see the black color point leads to 10. Okay, so then it is equal to 20 volt, and frequency is equal to, we can able to see, so for each half cycle 2 box, 1 box, 2 box, 3 box, 4 box, so 4 boxes into 5, so that is equal to 20 millisecond. Okay, so whatever the input you are giving, you are getting the corresponding output. Okay, so now finally I'm going to tell you what will happen when you are going the filter circuit. Okay, so filter, so this is the full wave rectifier, so I'm going to connect the filter. Okay, I'm going to connect the filter. கொஞ்சம் தூரமா வச்சிருங்க அப்பதான் அந்த blink இருக்கும். Okay, so you can able to see the thing because the light இருக்கனால அது அமுச்சு. Fine, so now I'm going to explain how to give with the filter. இது கொஞ்சம் ஆஃப் பண்ணுங்க. So filter, I want to connect in parallel to my load resistor. So as I said, there's a positive, there's a negative, so I'm connecting in parallel. Because it's very hard to insert in the breadboard. Okay, fine, it's got inserted. Let me turn on this one. See here, you can able to get a straight line. You can able to get a straight line. So where while you are measuring, it consumes one full box, 1.2, 1.4, 1.6 and 1.7. Okay, so with the filter you get 1.7 into this 10. So you are getting a 17 volt. Time period is equal to nil because it is a straight line, so time period is not applicable. So in the full wave rectifier, we have calculated the input voltage and current and output voltage and current, that is without filter, and with filter we are getting a straight line. Okay, thank you all. Thank you students.